Okay, I'm ready when you are.
Okay, shall we just start? Okay, so good afternoon. I'm Nicola Seriani from the ASESMA, and I'm going to chair this session. So welcome to the preschool, to the ASESMA. So we are going to have a few lectures we thought to leverage the possibilities offered um, by online interaction to anticipate some of the topic of the schools, in particular the more basic and more general topics, so to have more possibility to understand the basics um, well, but also to have an opportunity to understand who the people who would be more suited to then join us in person at the school. So to make sure that we understand, we get to know each other and so on. So the preschool will consist of a few series of lectures and a question and answer sessions. So there will be a lot of possibility, hopefully, to discuss things. And today we start with Richard Martin, who will give an introductory lectures on our field. And then there will be lectures by Javier Junquera on quantum mechanics, Garo Ghebreyesus and George Maniali on solid state physics, and Sara Bonella on molecular dynamics and statistical mechanics. So we will keep actually this time slot in the week. So next lecture will be next Thursday at the same time with Javier Junquera on quantum mechanics. So please try to follow us. And with that, I just leave the word to Garu, right? You are first, or
I think Richard is first.
okay. Then I will leave the word to Richard. So yes, thank you.
Okay, let me. It's a pleasure to give this talk. I get to give it because I've been around ASESMA since the beginning and been at every one of the meetings since 2008, which was just before ASESMA started, that pre-ASESMA, and in 2010 is when it really became a series. I will start sharing a screen, I hope. Okay, does that show correctly?
Yes.
Can you hear me okay? And does this show okay?
Yes.
Okay, good. So this is the introduction to the online preschool, and I get to give the introduction since, as I said a moment ago, I've been a part of ASESMA for so long, and I will be delighted that Garu and Nicola will describe the preschool more. So my job, see if it works. Well, now it's not changing. Let me see if I can. Oh, now it's gotten, oh, I see. When I shared a second ago, it didn't. Oh, now it's working. Okay, so this talk and my part will be about ASESMA since 2010. What is it? And then what is electronic structure? Since this is the ASESMA stands for the African School of Electronic Structure Methods and Applications. Why is electronic structure a grand challenge of science, and why is it so important in research today? The following talks will be, as we've said, by Nicola about the outline of the preschool and Garu about the in-person school in June. So ASESMA started in, as I said before, as a series in 2010. endorsed by the International Union of Pure and Applied Physics, and all along has been supported by ICTP primarily, and also other institutions and agencies. It's a school for every 2 years. And the idea is to establish a network. More about that as we go along. And so at first it was a 10-year program, and then it was renewed for another 10 years until 2030 by the IUPAP for a second decade. And this is because what it accomplished in the first 10 years. And starting then, it was expanded topics, and now it has grown to, we've already doing machine learning and a little on biology, but that's to continue increasing in the future, and other activities that I'll mention. So the approach from the beginning has been that computational science is important, and you can do world-class research with not too much investment in equipment. And computation is important in every area of science and technology, and therefore it's good to learn computational methods, even if you're not staying in this field. Choice of topics was electronic structure because it's an important enough field to really make a difference, and it's a small, narrow enough field so that people can work together. You can work together with people in physics, chemistry, material science, and other fields. And an assessment school is typically a half participants that are new to the field and a half returning. And that was very important as a part of the whole plan, is so that it's not just 2 weeks and then send people away. It's two weeks for a starting person, and then trying to maintain contact for those who are able to continue in the future. And that's why it's developed a network. And the school always contains lectures about the basic theory and hands-on for tutorials for everyone, and then projects also for everyone, in which groups will break up into small groups with a computational project. Here's the examples. The core topic is a density functional theory, and as I said, tutorials and projects. So the left-hand side is students working together in a hands-on session that's devoted to density functional theory, which I will describe in a little while. But it's not limited to just solids, which was the way we started, in fact, but involves quantum chemistry and molecular systems, and more advanced technique like many-body methods and spectroscopy. And here are examples with a leader, Mark Casita, who's one of the real leaders in the entire field of time-dependent density functional theory. The two of the leaders in the fields of spectroscopy, Matteo Gatti and Andrea Marini. In the tutorials, there are not just lecturers standing at the front, but mentors and others that are helping students as you go along. And more advanced things have come along as we are proceeding. And last year, this is one of the projects on machine learning with Alex Urban from Columbia University. And the coming year, rather I should say later this year, for ASESMA, molecular dynamics will be a core topic, as well as density functional theory, where one is learning the basics of statistical mechanics and moving on to tutorials and projects. So here's what's happened over the years. This is the schools that have happened every 2 years, and always in person, except for the one period during the COVID times when it was virtual. And in addition, there have been many regional workshops, which is an outgrowth of ASESMA, and as a workshop that can be smaller and not so expensive for people to attend, and generally more devoted to one topic or a few topics. So it was first in Cape Town, and for 2 times in 2008 for the beginning, and then 2010, and next in Kenya, then back to Johannesburg and Ghana, where it's going to be again this June. Did I skip that? No. Oh, there's 2018 in Ethiopia, 2023 in Rwanda, and the virtual meeting, as I said. The students, there were 279 participants total from 29 African countries. And here's a schematic of where these students came from. And these are, of course, in 2,000 participants, that's way more students than dots. And so in many cases, a dot indicates many universities in a given country. And the network of active research groups that has grown up, it includes at least this amount. I've emphasized it's a partial list, and it's because I don't know everything that's going on. And groups have grown up that are in our field, and they're an important part of electronic structure work in Africa. So let me emphasize, I want to come back to this at the end. Working with other people really is essential everywhere on the globe. That's an essential part of research. Working with other people, you learn, excuse me, learn about new things going on in the field. You learn about ideas, and you can bounce ideas off of other people. And working together locally, like at one university, people in chemistry, physics, material science working together. Regional things with nearby universities or nearby people, and very important is access and working with people in the global community. It's in working with the local people are the ones that you can bounce ideas off of and learn about our local capabilities. And the global community, you learn about the state of the art and new things going on all around the world, and contribute to the global community as well. So what is the science that ASESMA has been devoted to? I'd like to start with electronic structure is a real grand challenge of physics and chemistry, material science, and many other areas. I'll mention grand challenge in just a moment, but the reason for mentioning it the very first is that it's a deep intellectual field with many pieces. We've emphasized one of the areas in particular, but a person working in this area is really working with a large community. Pardon me. It's early in the morning here. And it's a field with real technological consequences. Up to solar energy, batteries, catalysis, magnets, nanosystems. All these areas are work on. So to be useful in these difficult grand challenge problems, then the results have to be accurate. There's a lot of detail required. And for this example, catalysis, where one needs to describe the molecules very well, and a solid very well, and how they interact very well in order to be useful. For batteries, one needs to describe the way atoms move through solids very well. Solar energy, the semiconductors. And the idea is to have basic understanding and basic theory that describes all these systems. But until the 1960s, there really was no way to make quantitatively accurate calculations for real materials. And I think it's no exaggeration to say that in 1960, there had been one calculation ever done that was quantitatively accurate, and that was for sodium in the 1930s. It's just too difficult a problem that I'll mention later. But in 1964 was the advance that made it possible for accurate calculations. It just was between night and day for the ability to do calculations. So the first steps that I'll describe next are the topics of the preschool. It's just getting going. Don't be afraid that when I go into some more advanced things, that's meant to show what's the possibilities. The idea is to start with real basics for everyone, and this year is the first year we've had an online preschool, and it's to get people ready and to provide information that helps get going, so the school, that's the in-person school in June, can be as successful as possible. And so the first step is basic quantum mechanics. The second is basic properties of electrons and solids, and and basic statistical mechanics that leads to molecular dynamics and other fields. So the next steps are what are in the school in June that's more advanced and lead up to topics that are current in the world of physics, and as I said, physics, chemistry, and material science. Okay, the first step, fundamental quantum mechanics, is based on the Schrodinger equation. And if we have one particle, this is what would be in an undergraduate course in physics, and phrased in different ways, but the same thing in undergraduate course in chemistry. Is the Schrodinger equation involves a kinetic energy. I mean, of course, it's the wave function that's the key to quantum mechanics, and the kinetic energy, the potential energy, a potential times the wave function, and the eigenvalue, the actual energy of the system. And this can be written as an operator, considering a second derivative and multiplying by a potential as a wave function, as a eigenvalue times a wave function. And this is a soluble problem. It's a second order differential equation. You can solve it analytically for many cases, such as a hydrogen atom. And with computers, you can solve essentially any problem, as long as it's one particle. So the next step is the problem of electrons and molecules, solids, and liquids. So the Schrodinger equation for many particles is usually written in a way like this, where the eigenvalue is the total energy, written with a capital E. The wave function is a function of many variables. We essentially never actually look at this function, but we know it's a function of all the positions of the electrons. And we have the same operators, the kinetic energy of the electrons, and this is just a symbol for second derivative of the x and the y and the z directions in 3 dimensions. And the potential is a Coulomb interaction due to the nuclei designated by capital letters. So if the electrons didn't interact, then it would just be particles moving in a field, and they would be independent, except that they have to obey the exclusion principle, and it's soluble. The ideas have been known since the 20s and 30s, and And with modern computers, then we can solve essentially any problem that with many thousands of particles. So it's something that's, when you see an independent particle calculation, you can consider that it's not only in principle, but in practice, a solvable system. And the reason that it's advanced is it's to do it efficiently for many electrons. Is one has to have efficient methods, which has led to the many codes that work very well and conveniently. The real problem, this is where it becomes the grand challenge. The real problem is many interacting electrons. The electron-electron interactions are Coulomb, just like interactions with the nuclei, and they mean that the electrons are correlated with one another. And this makes it a hard problem. This is a problem where we do not have exact solutions except in very special cases. And it's a problem that gets larger exponentially as you increase the number of particles, in this case, the number of electrons. And with modern computers, the very largest system that you can solve essentially exactly is about 10 electrons, and somewhat more actually, but not much. So in quantum chemistry, there are particular methods that are developed that one can go way beyond 10 electrons, but and still take into account the many-body wave function, which are very good approximations. And in solids, however, one is dealing with an enormous number of electrons, 10 to the 23rd, and so one just simply has to think about it differently. You don't write down a wave function with millions and millions and millions of coordinates. One has to think about it differently. And this is where density functional theory came in. Hohenberg and Kohn made a theorem. Excuse me. All properties of the system are determined by the ground state density, just a function in 3 dimensions. Now this sounds like magic. How can this be true? Well, the answer is everything is determined by the potential, and that's simply because one has to solve the Schrodinger equation, and you should be able to get anything, any property of the system. Hohenberg and Kohn showed there was a one-to-one correspondence. That is, there's only one potential that will give a given density as its ground state. So therefore, the density describes it doesn't describe, excuse me, it determines the potential. You have to know the density everywhere to determine the potential everywhere, and you have to know the potential everywhere to solve the Schrodinger equation. Therefore, all properties are determined by the density, but it gives you not a clue of how to make any way to solve the problem except to go back to the Schrodinger equation. Do you think that was worth a Nobel Prize? Probably not. The idea that was worth a Nobel Prize was the idea to construct a non-interacting auxiliary system. The idea was that, now, first of all, in 1960s, we knew that if we had an independent particles problem, then it would be soluble. And then as computers have come along, it's soluble for very, very complicated problems like real solids and real molecules. The proposal is that we'll get an independent particle with density equal to the real density of the full electron system. Now, so we have a soluble problem with the correct density as in principle. And if you know the correct density, as Hohenberg-Kohn said, you know other things. Like in principle, you know everything that has to do with the exchange and correlation among the electrons, the hard part of the problem. Now, in a sense, you still haven't solved the problem, because this functional, as it's known, that where you have to know the density everywhere, and that determines this exchange and correlation, it's still not known. But in practice, it's actually set up equations that formally are exact. And what it really did was gave a way to make accurate approximations. So the ability to approximate this functional is what made it so important. And that's truly Nobel Prize work. It's if you can write down a theory in 2 lines that's so innovative and so intellectually deep that gets a Nobel Prize, you've really done something. So how good are the approximations? In the original paper by Kohn and Sham, they proposed what's the local density approximation that determined the exchange and asserted that the exchange and correlation, the hard part of the problem, was the same as an electron gas, just an independent electron gas of the same density. And they're much more involved and much better functional since then. But still, this local density is just amazingly accurate and still used in many ways. And it's become an essential part of result because it's accurate. Applied to solids, you can generally predict elastic constants with like 1% accuracy, and photon frequencies of 5% accuracy, structures of molecules, nanosystems, many other systems that have now become an essential way of doing research in all these technological relevant fields. So sorry, I wanted to make another point here that this accuracy. Oh yes, the main point of the statement is these. When you say 1% accuracy, you don't mean that you tune up a problem. What it means is that one method and one code will be able to treat silicon, will be able to treat iron, sodium, a molecule of an organic molecule, just many problems with one method. So how useful is it? Kohn and Sham papers are the most widely cited papers in physics, and the citations have gotten to where they're to textbooks instead, but it's still the most widely cited papers. There are approximately 50,000 papers a year that use DFT. This is a real count in the sense that if the count was made in 2000, 10 years ago, of around 30,000, and certainly it's been growing since. So this is realistic. I did a little survey, is something that I just want to see myself. How does this actually work? And I look at Science Magazine. That's the magazine in the United States that covers all of science: biology, physics, ecology, geology, neuroscience, social sciences. And I look for works that involve atomic scale physics and chemistry and areas like that. Now, I've given this talk many times, and I've checked this many times, and each time I have done very recent issues of Science, and what I found in the last month was 6 papers that reported work on atomic scale research. They were all experimental papers, and 5 of the 6 used density functional theory as an important part of the research. And every time I've done the survey for many years, at least half of the papers use DFT as a part of the research, not as an afterthought, but as a part of the research. So let me go back. I want to say that I'm going to give 2 examples now, and the examples are ones that you certainly wouldn't think there's going to be some deep theory. So look at the next one. Here was a paper in January about growing wafers of a molybdenum disulfide film on top of the perovskite solar cell to make it more stable. And if you saw a paper with figures like this, would you think there'd be some heavy theory involved? Well, down in the text, you see, we perform first principle density functional calculations to investigate the phase transition, which has to do with how the molybdenum disulfide film actually bonds to the perovskite. Here's another one. Would you think that a paper that had to do with flexible electronics and actual things that you could wear on your hand would have theoretical calculations? Well, in the text, they describe optimization of the small molecules that were added to the system that was essential in making it flexible and strong. And this was done with a code from the chemistry literature. So I hope I've convinced you that the Kohn-Sham version of density functional theory is really useful for many things. But it doesn't do everything. Remember, it was set up to do the ground state. And that's just essential. That's the starting point. You need to know the structures of materials. You need to know what's going on, in order to start understanding the material. And the challenging part is that there's so many other things also to do in addition to the density functional theory of the ground state. And now this is a copy of the previous slide. And the only point of putting it here is to emphasize that this is also what's done in the ASESMA schools. And this year we will have more molecular dynamics as well. So ASESMA 2025 then consists of the preschool. This is the start of the preschool, and then the 2-week school in Ghana in 2025. And they will be described, whoops, it went away, didn't it? Oh, well, sorry. Now I can't see what's going on here. My system says that it can't display. Well, I can finish with words if I need to. Now it's covered up my.
Maybe try with another browser.
I'm not sure what happened, but I'll get it back in just a second.
Okay.
Well, let's leave it like this for the moment, because we can at least see it. So what's next is the schools is not the end of the story. What else you can do is be a part of ASESMA. That's the network of the network of scientists, and something called particular ASESMA that supports travel and interactions within Europe and meetings within Africa and with Europe. And look for opportunities. This is what I said at the beginning. To be an active researcher, one must keep up with current research and learn from others. To be an active researcher, it is important to be part of the field. Here's the sponsors that And it's really just a partial list of the groups that have sponsored ASESMA. And I'm going to go back and leave this up as the final slide. So thank you.
Thank you, Richard. So are there questions, comments? Does anyone wants to ask anything?
Prof, I think I have a question. All right. Is there a research network within ASESMA?
Is there a what?
Research network, as in from the former participants, have they like divided them into some group of research that during each ASESMA year, and they will come and give report of the research, what they have done so far from the knowledge they have acquired. I just want to ask because I have not been to the school before. Thanks.
Okay. The best source is this website that's mentioned on this slide, asesma.org, and a Slack channel that gets into more about what's actually done. And contact the organizers about any other questions you have. There isn't like a and there's a set of lectures that's organized by Omololu Akinojo, and that's going on that describe different aspects of the field that often are given by people that are associated with ASESMA. So it's ways like that to learn about it.
Thanks. So other questions?
Okay, probably let me ask. Richard, thank you for the talk and thank you for the overview. So could you comment a little bit on the challenges and maybe also opportunities of AI based to our community?
Oh, so it's a grand challenge. Exactly like I've said, there's people that have worked on this since the start of quantum mechanics, and in some of the areas that are considered most difficult are called strongly important, and other kind of areas that are so important are very large systems like proteins, for example, that are where it's very difficult to start from the electrons and work all the way up to things of the size of a protein. And in the end, we know that you don't really have to start with the electrons because the large, vast number of proteins all have very similar pieces, and it's the way they fold and the way they work together that's what determines the functions of the protein. So there's at least two kinds of areas that where the computations and the basic theory are really pushed to understand and to do practical calculations. In those areas, the machine learning and artificial intelligence have real possibilities for making an enormous difference, like the recent work that's described the folding of all the proteins that we know and proteins that have not been discovered in nature. So there's great possibilities for combining the efforts. And I'd like to emphasize that it's not just the giant computers and Google and Microsoft and people like that can do the calculations. Once the calculations are done by the people with the largest computers on Earth, then the output can be used by other people, and one can do searches and things on a small computer that can then do first-class work. So it's an exciting point in our field. Okay, that's about all I have to say on that. Yeah.
Thank you. So, other questions, comments?
Okay.
Well, then if until people are warming up to ask questions, Richard, could you also give like what would you project this ASESMA? Maybe we have already the white paper up to 2030, but beyond.
Ooh, this field is going to be important. And it will grow, and I think I'm not going to predict just what it'll be beyond 2030, but somewhere there will be interesting things happening in everything from solar energy to catalysis to new materials to higher temperature superconductors to just things that we don't really know, and materials are going to be important, and deep understanding of materials from starting with quantum mechanics is going to be very important. Garu is going to mention later the year of quantum science and technology that's happening this year, because it's recognized worldwide that this is important for humanity and not just our little field. So, but I won't make more predictions than that.
Thank you. Other questions or comments?
Okay, it's good to see all of you.
So maybe I can present in the meantime until they.
Okay. So the others people, you still have.
Oh, okay. So if you go ahead, I'll be staying around if there are further questions later.
Perfect. Okay.
Thank you.
Thank you, Richard.
Okay. I think I have to stop sharing.
Yeah.
Is that okay?
Yes. Can you see my screen, please?
Yes, I can see.
Perfect. Okay. So good morning, Richard, and probably I saw also Rio. I don't know what time is in Rio also. But for most of us, good morning and good afternoon. So I will briefly talk about the ASESMA 2025 overview. So my name is Garo Gabriesus from Department of Physics, University of Ghana. So the date of the next ASESMA, which is ASESMA 2025, is going to be from June 9 to June 20, 2025. The location is Accra, Ghana. Again, I saw on the chat some people asking about the application. So please, application will be available through ICTP website. visit the ICTP website regularly, but it will be also, once it's open, it will be shared through all the channels. So to briefly say about the host of the institution, so it's going to be in Ghana. And for most of you, you know where Ghana is, but just to say, Ghana is in West Africa, sandwiched between Ivory Coast and Togo. And Accra is the capital city of Ghana. And University of Ghana is in Accra. And University of Ghana was founded in 1948 as the University College of the Gold Coast. I think by then, when, I mean, during the colonization, when they want to establish a university, it was among Ghana or Accra and Ibadan. My good friend Omololo is here. I think finally they put it in Ghana first before Ibadan, but if there is anything, Omololo will also give us a bit correction on it. So this is the premium university in West Africa. So it is actually now organized in a collegiate system. There are 4 colleges, and the College of Basic and Applied Sciences where physics department is. And on the right, you will see physics department. It is also established in 1948, and it's within the School of Physical and Mathematical Sciences. So this is where we are going to meet in ASESMA 2025. And the local organizers are, the chair of the local organizing is Dr. Martin Iglobe, and the members are Professor Nanaama Brown-Kuriche, Professor David Dodo Ahin, and Professor Abu Yaya. And as you can see, Nanaama and Martin are from physics department. David and Abu Yaya are from material engineering, material science and engineering department. Actually, we are in 2 different schools, but we are basically putting together to organize this event. So if you have any question about the local logistics or local organizing related things, please contact Dr. Martin Iglobe with the email that I put over there. And I mean, Prof. Nana Ama was a former HOD now. She was our HOD, but now she's appointed by the president of the country to be the CEO of the EPA. And Prof. David Dodo Ahin he's also the director of the research, but we believe that they will be still active to support this event. Well, so I just want to say brief on what is really new that we are planning to do on 2025. So Richard already mentioned all the events or the details that we have been doing so far. And as a committee, I mean, at the executive committee, together with the planning committee, for this year, we want to do a parallel track from week 1. What parallel track means, we will have basically new participants, which we put them on the basic sessions, and advanced participants, which are actually going to be on the advanced sessions. And these 2 programs will be running in parallel from the first week, basically from Monday of the first day of the school. This we are actually thinking, especially with the advanced sessions, apart from the specialized topics to be covered, we are all anticipating to have early project initiation, which we think this would actually help to foster a long-term collaboration. And also by bringing these advanced participants to stay for 2 weeks, starting from day 1, will strengthen mentorship and networking. The mentorship is not only between the, African participants and international scientists, it could also strengthen the mentorship and networking within Africa. It could be between among the advanced ones or advanced and new participants. And this is the idea why we really want to start this advanced participant or session from day 1. Then, as Richard also indicated, this year is a year of quantum and science and technology. And it's actually an international event which was endorsed by UN, and Ghana is a country which endorsed it. And being University of Ghana is the premium university in Ghana, we want to have also a one-day event because we want to highlight the role of quantum science in material science and condensed matter. So these are the things that we think is something like not completely new, but it's something that we build up on what we have been doing so far. Just to say a little bit on the structure overview, we have week 1 and week 2. So as we said, in week 1, we have the basic session and the advanced session, which are going to run concurrently. And the topics are, as already Richard said in his talk, the basics are the ones that we have been doing, but this time we want to bring molecular dynamics and statistical mechanics to be on the basic session on week 1. This is also something that is really not really new, but a little bit restructuring to bring and give more attention to the molecular dynamics and statistical mechanics from the first week or starting from the first week. On advanced sessions, these are the topics that are actually somehow proposed, but more topics might come. So you have to always follow the ASESMA website, and then when the call comes out also, I'm sure more topics will come, but these are the ones which we have for now. And on the second week, we will have one of the participants, he asked if some former ASESMA participants or some people comes and give a kind of presentation. Well, this is the second week. We usually put it for special topic seminars where we always have, or we always try to have a kind of sometimes poster session, but sometimes also short type of presentations. But this is the second week where we will try to do all these type of things. For the time being, we have machine learning, SISTA, and strongly correlated materials. These are the topics that we expect in parallel by devoting quite a lot of time to do the project and presentations. And then on that second week, we will have the Year of Quantum Science and Technology event, which actually will have a series of talks on quantum computing, quantum in material science and condensed matter physics, which is going to be talks by a very distinguished scientists from the globe. And we will have one public talk, which is basically a public talk to the university community and beyond. In this, we are actually involving UNESCO, Ministry of Education, and Ministry of Science and Technology. They are very keen to come and support, at least for now politically. We will see how financial they will be supportive, but we are expecting their presence in the beginning and of course also in the public talk. Saying this, I just want to acknowledge, as Richard already indicated, the sponsors that have been involved throughout the school. I just want to take time, okay, University of Ghana for ASESMA 2025 have already prepared 2 computer labs that will be running for both the advanced and basic sessions or hand-on sessions. And then we will have also a small classrooms for small groups when it is needed. Apart from that, we, through the dean, we communicated through the dean to the provost, and the dean and the provost up to now are very keen to support the shuttle and also the food and coffee break. And we are in a process of getting or trying to, I mean, we engaged in different ministry offices, and we engaged also US Embassy, German Embassy, and some private funders if they can fund for the accommodation. We are hoping and anticipating to get some fund to cover the accommodation for the participants. If that is the plan, and the plan B is if that is not really working the way we wanted it, Then we will basically we have a plan B, which is the hostel in the university, which is like the price. In Ghana, hotels are extremely expensive. Just to mention, hostels are in the range of $10, but the hostels and the hotels are in the range of $110 or to $120. So that's the huge difference. So I will wrap up by saying, okay, we really thank you, ICTP, for ASESMA 2025. ICTP has already also funded. IUPAP has funded. This time, Marvel also gave funding or support to support African participants to travel from different African countries to Ghana. We are very thankful. And this time also through CHPC, they have already promised us that through Krishna to commit a computing time during the school, especially for the advanced participants, which might require a very expensive computational resources. So CHPC are also, South Africa CHPC are also helping us on this one. And I would like to thank you, everyone. And those who has been in ASESMA 2016, the picture is here, and we can take a minute to reflect in 9 years how much changes are happening on ourselves. Thank you very much.
Thank you, Garo, for this nice overview. So are there questions, comments? Okay, everybody, nobody has anything to ask?
I have a question.
Yes, please.
Hello?
Yes,
Yeah,
we
I can hear you.
Yeah. So would you give us training on computational resources or how to use HPC, things like that?
Well, my understanding is when this computational resource will be available only for the advanced participants. And of course, this type of training will be given by either online by Krishna. If not, we will do it from ourselves. But I believe that is what we expect, yes.
Okay. So these preschools, will it include training in basic Linux, how to use Linux operating system? Or is it just
No.
theory?
No, we don't foresee to provide that in the preschool.
Okay.
So
We will do it for the new participants during the first day in I think the plan was we have not finalized it, but the advanced participants together with some tutors will be dedicated their Monday afternoon to teach this basic Linux to the new participants, but it has not been finalized. So
yes, there will be this session, but still, if you're not familiar with Linux, with command line commands, with scripting, I suggest that you get some knowledge. Maybe you can ask us even for references, but I think this is something you can easily find on the internet or ask your supervisors, because it would be important that you are familiar with these things before you get there. So there will be a session, but it's difficult in a couple of hours to catch up. So, and this is very, very important. So
maybe can we put a link of some of where there will be always a copyright issue, a link in our Slack or in the website?
yes, we could share some information. I don't know myself where to look, but I guess something like basic Linux commands should be easy to find. So
I think we can do that.
yes,
Myself or Omo, we can just pick and put. It's always the issue of copyright. So
yes, no, but because we don't share ourselves, but I think there is also a lot of free materials on this. So Victor is raising your hand. Please unmute and ask your question.
Yeah, all right. Thank you very much for the talk and for the overview. So I want to ask, since you said that the computational support will only be for the on-site school. So I want to ask that what will be the limit of computational power that I should have remain on my local system?
You mean on your laptop?
Yes, certainly.
Usually the basic exercises are very light. I don't know what exactly the limit is, but we are not talking about several gigabytes of memory. I don't know exactly what's exactly. I cannot tell numbers. Probably the best thing is for those selected, and we can discuss also with the leaders of the hands-on sessions afterwards. Yes. So who was I didn't know. I don't know who was first. Otieno.
Yes, thank you so much. I hope I'm coming through. And I also want to appreciate the good session that we have had. It's just my suggestion because it is impractical that everybody will be selected to join. My question is, for the hands-on specifically, will there be an online session? Because it will be of very great help for those who will not attend or those who will not be lucky to be selected. Thanks.
No. We've seen that it's already quite complicated to manage the in-person session, and having a part of people there and a part of people online is really not practical. For those that will not be selected, first there are many online lectures, for example, on the Quantum Espresso website of former schools with slides, with videos, and with the material. So I suggest to start from there. And second, there will be other opportunities. I mean, after the school, there will be other events going on. We have regional schools from time to time during the year. So it's not the end, let's say, but we will not have an online part of that school. So thank you. The next is Adewale. Do you have a question?
Yes, good afternoon. I just want to ask that if one is having a problem with running a code, let's say I try to submit the code to run and there's an error and I'm not able to figure out the error. Is there a platform where I can maybe show my code for any possible correction?
Well, what code are you talking about?
I'm in a Quantum Espresso code to run,
Well, there is a forum of Quantum on the Quantum Espresso website where you can look at all what kind of problems people have had in the past.
Mhm.
And the first line is to search through the forum to see if anyone has had a similar problem. That's the first line. Otherwise, you can, after you've done that, you can post your question yourself to the mailing list of Quantum Espresso, and if you're lucky, somebody will answer. But often people answer. So.
Oh, thank you. Thank you.
Our Slack is also active, right, Nicola?
Yeah, there's not too much life there, but yes, in principle, it's active. So the Slack of ASESMA is also a place where to discuss these things.
Exactly. If you need a little bit special type of attention, maybe it's always good to go to the community so you can drop your question over there. But checking the Quantum Espresso users is very, very helpful. The same problem might be discussed over there already.
Yeah. Any other question?
There is a question on the chat. What is the criteria for admitting participants into the school?
Good question. Very good question. So Well, the committee will gather and decide exactly how to proceed. But usually, there are two kinds of participants: the beginners and advanced participants. And so with different sets of requirements, of course, in the sense that advanced participants are people that are already active in research and usually use the codes and so on. Still, I would say that a minimal set of requirements is being acquainted with the topics of the preschool, quantum mechanics, solid state physics, and as we said, all the computational side, Linux, command line, scripting. So this is a good starting point, not because we want to exclude people, but because otherwise it would be difficult to impossible to follow there. So our priority is really to make sure that the people that come can profit from the school. No, it does not make sense if you come there and you have problems understanding basic quantum mechanics. Then it's useless to be there. So I think this is more or less the main criteria regarding competences. Then the other big question is funding. No, so usually the main limitation is how much funding we have to support people to come there. So if you have your own funding to cover your travel, for example, assuming you are good enough, your background is appropriate for the school, well, that makes a difference because the funding we have is usually very limited. So yes, and I think that answers also the question by Damilar in the chat, right? So
Yes.
we will have funding for some participants, but that's usually quite limited. So yes, there will be funding, but of course, if you have other sources, please explore every other possibility you might have because that helps everybody and enhances your chances of being accepted, provided your basic background is solid enough for the school. So yes. Mekuria, you have raised your hand, please.
Yes, thank you. My question too is around the requirement for admission, so especially for the beginners. So are you looking for a master's or PhD? What educational level are you looking for? Thank you.
Okay. Okay, so formally we don't write down we want a bachelor or a master's or a PhD. So for us, it's more than your current enrollment situation. The important thing is your level of competence. So when you come, will you be able to follow or not? That means if you are a bachelor, first year bachelor, you're studying classical mechanics, you are not eligible. I mean, you will not take you very likely, no? That's so our first priority is to make sure that if you come, then that's you have the possibility to follow and to learn and to interact with the other people that are there. So again, if you are in the PhD but you have not you don't have a background in solid state physics, then that also makes it unlikely. So in practice, most of the people, well, I would say there are more PhD students than master students usually, but and I think in the past we also accepted final years bachelor students, but that very much depends on your background. So yes. So is there any other question, comment? So yes, but we know also that in the end, many good people that we would like to have, we will not be able to take because funding, space. So in the end, but don't get discouraged because ASESMA is also other activities. There are the regional schools. We in the last years we've had 1, 2, even 3 regional schools in a year in different places in Africa. We have the exchange programs, ASESMAnet. There are online activities. So the mini lectures that have started last week and will continue, I think, from March. So there are many possibilities to learn, but also to interact, and also hopefully to find a research collaborator. So yes, that's the point. So, any other question or comment?
Yeah, I think we can probably, Omololo is also leaving. If they don't have questions, we can